Hi everybody, it's Mr. Wader here, and before we get started with the new information for today, I'm going to start off by telling you first, make sure you grab the periodic table of ions, either have it open on your computer or print a copy out if you can. Just make sure you're able to look at that. If you need to pause the video to take a look at that, feel free. And also, I have the examples from the last class. So, to start at the top here, we have strontium and bromine. The first one is the metal in all of these, and then the second one is going to be the negative charge, so positive, negative. And your metal always goes first, which is the positive. So if you take it SR on this table, it's strontium. So the first one is strontium. And the second one is Br. Br is element 35 that is called bromide when it's an anion. That's the negative one. Next up is LaF3. La is lanthanum. All the elements after it in that row, by the way, are called lanthanides because of that. It's called the lanthanide sequence. So that's lanthanum. And you have F after it. F is right here, which is fluoride. Li is lithium. S is sulfide. K is potassium. And Cl is chloride, so that's potassium chloride. You can get potassium chloride in Powerade and Gatorade, actually. Then you have BaO. Ba is barium. That's what you do with all the bad chem jokes. Get it? So that's barium, and O is oxygen or oxide. Then we have Ti, which is titanium. And we need to pause for a second here, because titanium has more than one charge. So we're going to have to do that in a sec. Then we have F4. So that's going to be fluoride. And the example below this is the same. Titanium fluoride, but we need the charge. So if it's F4, and this is what we're going over today. F4, fluorine, has a charge of -1. If you look at titanium, it can have a charge of +4 or +3. So one of those makes more sense. If there's 4 of these, that means that is 4 plus that we have to get, because 4 of the fluorines is 4 minus. So that would make this titanium 4 fluoride. And then this, having 3 fluorines with a negative charge, that's -3. So we need the 3 plus for the titanium. So that's going to be titanium 3 fluoride. Okay. Also, there's a couple at the bottom that have complex ions. If you take a look at the chart here, NO3, we need to find NO3. So NO3, it's in this chart. Nitrate is NO3. It has a charge of -1. And silver, Ag, has a charge of +1. How convenient. So that makes this silver nitrate. Silver nitrate, really important stuff. They actually use it to help cauterize the umbilical cord after a baby is born, and other things similar to that. Anyways, we're going to be doing ionic compounds as we had been so far. And in order to make these, you have to balance out the charges, as you had seen in a couple examples already. Now, sometimes that's pretty easy, like zinc oxide. Zinc has a +2 charge, and oxide has a -2 charge. So that's simple. +2 and -2, when you put them together, cancel. And your goal is to make sure you have the same amount of positive and negative charges, because all ionic compounds are neutral. That's just naturally how they form. And then the next example is lithium sulfide. I bet without going any farther, you could probably figure out how many of each you need. But the goal here is to make the charges cancel out to 0. So zinc and oxide cancel. and you would need 2 lithium and 1 sulfide to cancel those out. Once you've canceled them, they're balanced. And if they're balanced out, they're neutral. When you're done, you're all set. So the formulas would be ZnO, because you only need 1 of each, and you don't have to write the number if it's just 1. And the next one is Li2S, because you need the 2 lithium and the 1 sulfide there. Sometimes this gets a little bit more complicated, though. For example, you have aluminum oxide. So how are we going to balance these out? Well, you could try 1 of each, and if you did that, it wouldn't really make much sense. But I'm going to try and use a really simple technique just to show you why we balance them the way they do by using pluses and minuses. So aluminum on its own makes a +3. That's the same as having 3 pluses. Okay, oxygen makes -2. That's 2 negatives. Notice if I put 1 of each together, it didn't cancel properly. Okay, well, then you add another oxygen, right? So that's 2 more minuses. And then you cancel. Well, now we have an extra minus. Okay, let's add another aluminum. +3. 1, 2, 3. That cancels. Now you need another oxygen. Notice how time-consuming this is? Okay, we canceled it. We needed 3 oxygens and 2 aluminum. So we know the formula is going to be Al2O3. But I bet there's an easier way to do this where we don't have to sit there and draw pluses and minuses all the time. So why don't we learn that way? Seeing that would be pretty helpful. So you can do the same exact process a couple of different ways. But first, the reason that didn't balance is because there's not a 1-to-1 ratio in the charges there. So you have to find the right ratio. And this is based off of its charges. There's 2 ways that I like to do this. If you go online, you can find other ways, but these are the 2 I think are the easiest. So if you take the charges, that tells you how much of the other one you need. And then if the numbers can be reduced smaller, you can do that. So for example, we have Al +3, and we have O2 minus. If you take the 2 minus and bring it down to the aluminum, that gives you aluminum 2. If you take the +3 from the aluminum and bring it to the oxygen, that gives you O3. So if you neaten this up a little bit, you get Al2O3. Okay, now that's the simplest way to do it, but it doesn't explain why it works. The next way explains why it works. This is called least common multiple. If you were ever amazed by magic tricks when you were a kid, the math ones, like the ones where it's like, all right, flip a card, what's its number? And then they give you a bunch of sequences. A lot of those are actually solved mathematically by least common multiple. They're trying to abuse a little math trick to make sure that the numbers, no matter how you play this out, will work out the same way. Well, least common multiple is the way we do that to solve these problems in chem. So for the same example, you're going to look for the number they both multiply into. So in this case, you're looking for 6. And that's because if I multiply 3 and 2 together, and that's the charges we're working with here, 3 times 2 is 6. Our charges are +3 minus 2. Okay, so if you're getting to 6, how many positive 3's do you need? You would need 2 positive 3 charges to get +6. And for your O2 minus, your oxide, you would need 3 of the negative 2's to make -6. If you have +6 and -6, that cancels, right? So that would show you need 2 aluminum, right? Because you need your 2 3+ charges to get there. That's right here. And you need 3 -2 charges to get -6 here. +6, -6 cancel. Okay, so now we're on the document. This is the exact same as the one that you have on slides. I just wanted to use Microsoft Word for now to do this. So you can do this either on a blank piece of paper. You can print out a copy of this document and fill in the blanks there, or you can just complete the blank examples in here. I think it's a little easier if you write this by hand, but to each their own. I wanted to do 2 examples out of here. I wanted to do a couple of specific ones. I wanted to do cobalt fluoride, and then I wanted to do this one here, Pb2S. Okay, first, cobalt 2 fluoride. I'm choosing this one because it's an element that makes more than one charge. If you look at cobalt, cobalt can make a +2 charge and a +3 charge. So let's figure out how this is going to work. Cobalt 2 is telling you it has a charge of 2. So that's cobalt +2. And then your fluoride, if you take a look at the periodic table of ions, that's the one I linked there, it's F-. So I'm going to do this the simple way. I'm going to look at the charges, and that's going to tell me how much of the other one I need. I've got a +2 charge on my cobalt, which tells me I need 2 fluorides. This is the same as -1 for fluoride. That means I need 1 of the cobalt. When I put that together, that gives me CO F2. Okay, you could have also done this by using the pluses and minuses. Cobalt 2+ and F-. You would need 2 of the F's, 2 fluorides, to cancel out 1 cobalt. And then the last thing you could have done is gone, okay, I need to get up to a charge of 2. +2 times 1, that's 2. So how do I get -2? I need 2 of the negative ones. Okay, so now on to the last example here, which is Pb2S2. A little jump cut because I realized that I had the wrong formula there. So anyways, if you take a look, Pb is lead. Fun fact, in Latin, plumbers used lead. So plumbum, plumber. So they have the same name, actually. They come from the same idea. The plumbers use that metal, lead. Anyways, so the first element is lead, and there's 2 of it. And then we have sulfur, which there's 2 of it. And if you take a look, sulfur is called sulfide. So we have lead sulfide. Okay, you might think we're done. We are not. If you take a look, lead has more than one type of charge you can make. It's element 82. And right here we have listed +2 and +4. Lots of those metals can make lots of different charges, but we have 2 options here. So it's either +2 or +4. So sulfur is -2. If there are 2 -2 charges, that means the sulfur is giving us -4 as our charge. We need to cancel that with 2 leads. So if you were trying to cancel that, you would need +4. So that means you need 2 lead 2s, because we know there's 2 leads right here. It's in the formula. So that makes us lead 2 sulfide.